morning, everyone. I'm Liz Fernandez with the APHIS Training, and I'd also like to welcome you to today's webinar. Our speaker today is Dr. David Meeker. Dr. Meeker is the Senior Vice President of the North American Renderers Association, also known as NARA. He serves as their advisor on science, regulatory, and animal health issues. He is also a research director for the Fats and Proteins Research Foundation. He previously served in scientific and management positions at Turkey and Pork Associations. He was a staff director at the National Academy of Sciences and associate professor at the Ohio State University. He has advised numerous governmental, professional, and business organizations. He received his BS, MS, PhD, and MBA degrees from Iowa State University in animal science, breeding, and agribusiness. And with that, I'm going to turn the webinar over to Dr. Meeker.
Thank you, Liz. Well, good morning, everybody. I'm speaking to you from the NARA, Ohio office, which is my house. I'll tell you a little bit about the North American Renderers Association. We are a trade association, and we represent more than 95% of the rendering capacity in the U.S. and Canada. Our members include independent renderers and integrated packer renders. And those are the ones that process their own byproducts from food animal slaughter. And NARA also manages the Fats and Proteins Research Foundation, which focuses research on the industry needs. The rendering industry in the U.S. and Canada has about 170 facilities, plus 10 in Canada. Our annual revenues are about $10 billion, depending on markets, of course. And when corn was real high, our revenues also were a lot higher. And the same with oil. We process about 62 billion pounds of raw materials each year, and that's many, many truckloads of organic, quickly spoiling materials each day. This map shows most of our facilities across the United States. We're missing a few here, but the red triangles are the packer renders, the meat processors I told you about, and the stars are independent renders, which are the ones that provide additional services other than just byproduct rendering. As you all well know, animal production in the United States is quite a large enterprise with at least 33 million cattle, 125 million hogs, millions of sheep and billions of chickens and 250 million turkeys and so on. And nearly half of all of these animals is material that's not used for human food. So that amounts to about 56 billion pounds in the U.S. and another 6 billion in Canada. This data is from 2018 USDA data. Here's some estimate from also from USDA compiled by CattleFax showing that production continues to increase, so with a big increase in 2019, and even in our COVID year of 2020, we increased food animal production, and it's projected to increase again next year. So rendering is very important to the sustainability of these operations. The 62 billion pounds is cooked down to mainly two products, and that's protein supplements for feeds for all different kinds of livestock and pets, and tallow and other animal fats that can be used a number of ways, including feed, but also biofuel and oil chemical. The raw materials are really mostly offal, bones and fat, blood and feathers. And these first four categories would be done by all renders, the packing houses as well as the independents. Then the rest of the list are additional services provided by our independent members. That includes dead stock pickup, animals that die in transit or on farms, restaurant grease or used cooking oil, UCO, recalled meat that's already been offered for retail or on its way to retail, outdated retail meat, and butcher shop scraps. So these services are very important to the communities. The total, I'll go over details later, but the total amount that dead stock provides to raw material is about 4%. So the vast majority of these materials come from slaughter operations. To renders, these are very pretty pictures. This is couple pictures of raw material, and we turn this kind of stuff into this kind of stuff. And the process really does repurpose these materials into very good, high-quality, usable products. Different examples here from our members' websites. Our markets are pet food and all the different poultry and livestock feeds, and then the fats can also be used for biofuel and oil chemical, and the proteins can be used for organic fertilizers, and there's some market there. This shows similar information. Fertilizer is missing from this chart, but mostly concentrating on fats, and then at the bottom, all the different kinds of things that are made in the oleochemical industries, everything from ingredients for tires to shampoos and so forth. So in summary of the introduction there, our main message these days is that the using rendered products for animal food and pet food makes animal agriculture more sustainable. It saves acres of cropland by making these byproducts into safe feed ingredients. It reduces food waste by repurposing these materials. It provides U.S.-based jobs and economic impact, and generates fewer greenhouse gas emissions than other disposal methods. We have a lot of science behind each one of these statements, and a lot of that material is available on our website, NARA.org, and I'm not going to go into a lot more detail on that, but these are our selling points to make sure that rendering plants are considered essential industries in their communities. I'll talk a little bit about our process. On a very basic level, rendering is cooking and drying. Most of our machines these days are continuous flow and look like the cookers in this picture here. They're run by steam, and they cook product at high temperatures for 40 to 90 minutes. Now, this is designed to break down the cell walls and to efficiently separate the fat from the other materials. And we've learned through our research that the inactivation of the bacteria, viruses, protozoa, and so forth happens very early in this process. So the process is designed to break down cell walls, and it's far longer and at a far higher temperature than that's needed for food safety. So there really is no question about the safety of these products after they come out of the cooker. This is a flow chart that we used way back when we developed HACCP programs, and we still use it to identify the critical control points or process controls that are necessary for food safety, and we concentrate very much on that. In fact, we developed our rendering code of practice about 15 years ago and introduced it to the industry, and we developed good manufacturing practices that are now called CGMPs and FSMA. I'll explain FSMA a little later, and process controls that are called preventive controls now in FSMA. And we concentrate a lot on training. We have training programs for our entire industry each year, and we had to do it virtually this year, but we'll get back to normal hopefully next year and have another PCQI training. Preventive controls, qualified individuals. We do training on that. That was legislated and regulated into existence by what we call FSMA, that's the Food Safety Modernization Act. This did not impact meat slaughter. USDA inspected meat and poultry is not covered by this, but all rendered products are covered, as well as other feed ingredients and complete feeds. So this law was passed about 10 years ago by Congress, signed into law by President Obama, and over the next few years there were extensive FDA regulations promulgated on this legislation. And it requires preventive controls, like our cooking for hazards, and it requires current good manufacturing practices called CGMPs for virtually all the operations in the plant to make sure that the conditions exist for safe food production. I will say that rendering has been and continues to be the most scrutinized and most inspected of all the different feed ingredient producers. We've been under the watchful eye of FDA and states for a long time. We're used to it. We're very proud of our high compliance rate, and it's something that we deal with, and we're proud of being able to do these things well. So a little more specific, we really have one main process control in rendering, and that's our cooker. It is critical that sufficient temperatures are attained, so cooking is a critical control point or a preventive control in the new vernacular, whether it's a HACCP program or the newer hazard prevention programs. So these cooking temperatures, as I showed you, whether it's a continuous flow that I had a picture of or the old batch type, they're now computer controlled, and cooking temperatures are very closely monitored, controlled, and recorded. So there is no question about any product being undercooked. It just does not happen. We have verified our kill step with a number of research studies at Clemson, Texas A&M, Colorado State, Texas Tech, and so on. We validated that killing Salmonella, Clostridium, and E. coli are killed. We've done some work on avian influenza virus and other viruses, and that work continues. This graph I'm showing here, it really shows what you might call a failed experiment, but it's really good data. We were going to look at cooking temperatures in the rendering cooker and find out when Salmonella was killed. Well, at time 0, they were all gone. So during the warm-up period, we killed all the Salmonella in these spike samples, which gives us good confidence that it's a safe kill step. And we have other data that develop the D values and Z values and all the technical things it takes to validate cooking. Then as I said, about 15 years ago, we introduced or we accumulated a lot of what was already happening in rendering, but we made a formal program to raise the bar and make sure that plants that weren't as clued in as some of the others, that everybody had the same information. So we developed GMPs, and which now have evolved into CGMPs using FSMA language. But we have GMPs on personnel and training and sanitation of the workers, plant and grounds, sanitation of the plant, the water supply, plumbing, equipment, operations, holding product, distributing product, and then holding byproducts that may not be further processed. So this is all covered by FSMA regulations. Every plant is required to have a trained person on site called the PCQI that I talked about, and we're highly regulated. We have another study, and I've only got one slide on it, but we collected data with our partners in the Pet Food Institute and the American Feed Industry Association, AFIA, last year. We published this data earlier this year, so it's on each of our websites about all the byproducts going into pet food. Out of the 8.9 million tons of rendered proteins each year, 1.5 million of that goes into pet food. Of the 6.3 million tons of refined animal fats produced annually, a little over 250,000 tons of that goes into pet food. And then another 1.8 million tons of fresh and frozen meat byproducts coming out of slaughter that's not rendered goes directly to pet food, and then they do the kill steps there, except for the very small amount of marketed raw pet food, which is not recommended by us or FDA, but that does exist, and they have to have other methods of proving their safe food. I'll switch gears a little bit now and talk about our collection of fallen animals or dead stock. That could be a source of risk, not from the cooked product, but probably from the trucks going from farm to farm. But it's an important step, and actually in Europe, it's considered a very important way to stop disease cycles because, as I already mentioned, the typical pathogens are easily killed by the lethal temperatures on our rendered cookers. So it's important, and it can be done safely. The renders that do dead stock collection have the same regulations. They're under the same scrutiny as all the other rendering. They have process controls, preventive controls, and it's very well done. And alternatives, if you don't have, there are some areas of the country that don't have access to our services. Cheaper methods just don't have the biosecurity. Landfills, burial, composting has to be done very carefully to reach critical temperatures, and usually is not. And unfortunately, sometimes the alternative that farmers use is simply abandonment somewhere in the environment. And these things, these other things, other than rendering, are not uniformly regulated in the United States. And some landfills don't accept carcasses. Some states restrict burial, and abandonment is a lot more common than we'd like to see. So rendering is very important. As I mentioned before, dead stock, that's what we called animals that arrived to a plant that didn't make the transit, and in many of these slaughter plants they're picked up by a different render, or they die on farms. All that material now is about 4% of the raw material. Actually, this country could do better if we did more of the dead stock. We don't get near all of it into rendering. This material is suitable for animal food, according to the FDA, as long as the preventive controls are in place and the hazards are taken care of, which they are. Even so, many pet food manufacturers specify that they don't want any dead stock in their materials, so that's accomplished by the render, and we have many separate lines. And unfortunately, those discriminations against mixed species proteins or proteins that include some of this stock are really far undervalued. So that hurts the markets, which might hurt the long-term viability of these plants that are so important in communities and so important to some producers. So a few things I want to emphasize is that, in some of these outbreaks, the moving of trucks from farm to farm has been implicated, and probably rightfully so, but it can be done safely. And I'll go through a few slides here on how it can be done safely. But these trucks are specialized trucks almost all the time, owned by the renders themselves, and they keep these trucks clean and leak-proof. Oops, went the wrong way there. Really, if a producer wants to have rendering services for dead stock, they should develop a plan, and they should observe the line of separation between the farmer operations and outside trucks. This probably should apply to feed trucks as well, and then anybody providing materials for the farm shouldn't cross that line, particularly the rendering truck. So here's a couple of different maps of layouts and the line of separation that is called. Here's a dairy farm. Really, the dead should be off the farm, and they should be outside that line of separation. It should be in containers, hopefully out of sight from the neighbors and the passersby. These plans need to be developed for any swine operation, but should be developed in consultation with the rendering plant. And we have many plants that do this with their swine producers. They work together, and they make sure that the timing and logistics are done in a safe manner. And it's an agreement between the producer and the render. The mortalities also need to be secured by a fence or a container from wildlife carrying them around. Neighbors' dogs and so forth can get into those piles, and that's not good. And as I mentioned, it's best to keep them out of sight. Many of our plants do routine truck washing, have washing bays in their facilities. And in the porcine epidemic diarrhea outbreak a few years ago, many of them added extra procedures during the outbreaks, such as disinfecting wheels and wheel wells between farms and so forth. And these are things that probably need extra attention all the time, but emphasized more, obviously, in a disease outbreak. There's been many conversations and with Dr. Jack Shear at APHIS and others and state veterinarians about whether rendering is an option for depopulation in a disease outbreak. Earlier in 2020, we found out that with the COVID situation and the temporary plant closures, that rendering became a very good option for taking care of some of these surplus pigs. But it's a little different with a disease outbreak. So some renders, only independent renders would be interested, and some of those are interested, but it depends on conditions. There's a number of questions, concerns, and so forth that need to be discussed and policy developed before that could take place. And we all should have this plan worked out before a disease outbreak and not during, because as we all know, that doesn't work all that well. So what our concerns about maybe using depop rendering for disease depop is obviously the biosecurity. We don't want to have any liability or cause of disease spread. But we do know that the transportation of these carcasses can be done securely if the right resources are used and the right procedures are used. But the markets for finished products could be impacted. Even though we can prove they're safe and the heat process makes these things safe, customers may not want to buy these products. So we'd have to discuss the disposition of these products. Even if you had to landfill the meals, it'd probably be worthwhile to render, because you're taking out 60% of the volume by taking the moisture out. There are questions about what it would take to get facilities back to operation after handling known infected birds or animals. As I mentioned, there's a problem with the perception of the products and communication about what's going on. If there's no market for the materials, there has to be some sort of compensation for this activity, and we need a plan in place before a disease outbreak. Well, what more could be done on the dead stock front? As I mentioned, fallen animals or dead stock is only about 4% of all our rendering material. Only about 40% of the cattle are rendered. That means 60% are not. I'm not sure what the percentages on pigs is, probably similar to that. So some sort of incentives to the producer to send these animals to rendering might increase that percentage and benefit the environment and benefit disease control. It's common in Europe for the county to pay for the transportation and the pickup of the dead animals, so the producer has incentive to put those in the right channels and not have them laying around the farm or abandoned. So really we could do better in this country on dead stock handling. Now I'm going to shift gears, and there's been some concern about blood products, and for the most part, blood products are not rendered in the process I already told you about, but they're handled in other safe ways. So I'm going to go through some of that now, because they are also byproducts handled by our members. The main concern has been around since the 2013-2014 porcine epidemic diarrhea outbreak, and the concern was that spray-dried porcine plasma was viewed then as high risk and likely responsible for the spread of PED. And Scott D's research and others, K-State and so forth, has shown me at least that the possibility that viruses can survive in feed and feed ingredients, I still don't see it being a high probability, but it is possible. Well, the response of the industry to that viewing of porcine plasma as the cause of this was to fund a risk assessment at the University of Minnesota, to define and validate the multiple hurdles used in porcine plasma production, and to further investigate some of these outbreaks that took place. In fact, we did a much deeper dive into the Canadian outbreak in 2014, where the Canadian Food and Ag Agency did a quick analysis, and you know, understandably so. They wanted to quickly find out what was causing the outbreak and stop it. They did a quick analysis, and they pinned it on porcine plasma. We went back and looked at all the factors, and this paper was published early this year. It's easy to find, and really their conclusion was most likely in error. The paper's easy to find, and the details are there, and I'll just highlight the points that we emphasize out of there, and that is that the PED virus, the paper says may have been, I'll say most likely was present in Canada prior to their identified index case, and it was in herds that had not used plasma at all. A likely cause could have been, you know, there's many trucks going to U.S. slaughter plants every day from Canada, and these trucks were returning to Canada with very minimal and, in some cases, no cleaning at all. So those trucks could have carried PED from the U.S. back to Canada. And just like the U.S., Canada imports feed ingredients from many countries, including China, the U.S., and so forth. And there was many non-animal feed ingredients that could also have resulted in the introduction of PED into Canada. And they jumped to the conclusion that something must have gone wrong in the manufacture of the plasma proteins to cause this problem. Well, I got to say, the traceability and the production records of these companies that made this plasma protein is impeccable. There's just no support for the suggestion that there was a breakdown in manufacturing procedures, because it's well documented, and they knew exactly where this product came from that went to those index farms. So the conclusion, well, that ends the Canadian study. There was other investigations of U.S. outbreaks, and I have not seen any to date that made a good connection between any feed ingredient and PED outbreaks. So we know it's possible. We just haven't seen it really happen and be proven to happen. Well, so that conclusion by veterinarians in both the U.S. and Canada that they couldn't figure out where it came from, so it must have come from the plasma. That elicited, obviously, a response by the plasma producers, because it's their market and their product. So they have invested significant resources into researching additional inactivation technology on top of what they were already doing. They did extensive validation studies. They've characterized the viral load in commercially collected plasma. They did extensive upgrades in plants and warehouses, enhanced biosecurity, and so forth. And I'll go through a number of those steps now. I think it's important to understand how these plasma proteins are made, so we'll do that now. The risk assessment at the University of Minnesota was paid for by APC and SONAC. Both of these are members of NARA. They evaluated the combination of the three inactivation hurdles that are applied in plasma production. Those include the spray drying process itself and the post-drying heat treatment. That'd be the warehouse. That's the baseline. That was always done. And then since this outbreak, they have added, some plants have added a UV treatment, ultraviolet light treatment, and some have added an additional dry heat pasteurization step. So the Minnesota risk assessment analyzed these two scenarios and found a 10 log reduction for all viruses studied in the baseline plus UV, and a 8 log reduction in the baseline plus dry heat. This slide's a little busy, but I'll just go through the blood collection. It's not you know, the old-fashioned way where the blood falls on the floor and goes through a concrete gutter to processing. No, this blood is collected right at the stick. As soon as the jugular vein is cut, there's an elevated usually stainless steel trough that collects the blood that immediately gets it out of the slaughter area. After it's collected, it goes to a separate room where it is separated and stored in insulated tanks, then transferred to a separate facility. I have a little trouble here reading my own slide; it's too small. But I'll go through some of those steps in more detail here. So at the slaughter facility, it's taken away from the sticking area into a separate room, and these are clean rooms, and it's separated from the red blood cells are separated from the plasma, and then it's chilled and stored in a tank. Soon after that, it's taken to a separate facility. Now, this slide is very busy, and I'll show you some of these surrounding pictures in more detail in a minute. The important diagram here is the one in the center, and these plasma processing plants remind me of plants I've been in that make ready-to-eat lunch meat. They are very clean. There's a wet area and a dry area, and there's no crossover without biosecure procedures. They're very access controlled, and just a very good way to produce safe product. This is a picture of a room in one of those facilities where they have the configuration of tubes to apply UV light, and it's designed so that every cell has exposure to the UV. There is biosecure separation between the rooms, between wet and dry. There's hand washing stations and boot washing stations between every barrier. If they go from the office to the wet area, if they go from the unloading bay to processing, if they go from processing to dry, or from dry to low out, each one of these has an intervention where they do the cleaning. I already showed you that slide. I got it in there twice. This is a picture of the bottom of the spray dryers, where the temperatures are closely monitored. It's obviously a lower temperature than I talked about in rendering, but still monitored. Now, the reason these are done at a lower temperature is that the value of these plasma proteins is the function of the proteins. In a normal rendering process, we're just worried about the nutritional value of proteins. So it can be denatured, it can be heated, and so forth at high temperatures, and it still has the nutritional value. Plasma protein has a nutritional value, but it also has a functional value. So you don't want to abuse these proteins to lose the function, and that's why it's necessary to go through these multiple hurdles instead of a high heat process. Now, the other blood, the blood maybe in some plants still does hit the concrete floor and still does go through that gutter. That might be made into whole blood meal, and that's a different process. That's a ring dryer that has injected steam, so that's a fairly abusive process too, and they would have a functionality, but it's a high protein product for nutrition, and there's really no concern about the safety of that product. So after the plasma is spray dried and it's packaged, and it's always new packages. They don't use any recycled packaging like has become a concern for Chinese products and other products. It's packaged and put in a warehouse where the heat is controlled. It stays in here for 2 weeks at 20 degrees C. One of those pallets is a Sentinel pallet that has probes in it, and it monitors not only the ambient air in the warehouse, but the internal product temperature for those 14 days. And that's one of the several hurdles for the multiple hurdle technology. Now that's a term that's used and recognized and applied in food production, and there's science on this and published papers that show that the multiple low-level mitigations, when applied result in a log reduction that's greater than the sum. So there's some synergisms going on there, and it's a well-recognized way to provide food safety. Here's some research on specifically on spray-dried porcine plasma. With a list of viruses down on the left side, porcine respiratory and reproductive syndrome, SIV, porcine epidemic, diarrhea, SVA, PPV, and then some viruses that we're more concerned about: classical swine fever, swine vesicular disease, African swine fever, and pseudorabies virus. Now, these last four, the log reduction in storage is still being developed. We don't have that validation data yet, but the two hurdles listed here, the spray drying and the UV light, added together give well over 10 log reduction of any viruses that might be present in that raw material. So a variety of different viruses here has been proven on. A number of them have data on the storage step as well. So then after those hurdles in production, that's the spray drying, the storage, and then UV light or another pasteurization step, there is even another one. After the 2 weeks in the heated warehouse, it spends another 2 weeks in the regular warehouse, so it's 28 days that they go back and check the areas where this material came from. As I said, they have impeccable traceability. They go back to where this blood came from to make sure that none of these areas broke with ASF during those 28 days. So 28 days after harvest, when they check the status of those areas, then that product can be released for market. There's ongoing work. There's experiments right now going on in Spain. This data should be published fairly soon. There's experiments being conducted at a BioLevel 3 facility in Spain where they took serum from infected pigs infected with African swine fever, and they took that serum and they added it commercial unprocessed plasma, and they fed this plasma to pigs to see if it would make them sick. Two different experiments. They fed it for 14 days, a couple of different configurations here, and none of these pigs got sick from that contaminated product. They took that same product and injected it or gavaged those pigs, and they could make them sick that way. So I think this calls into question, again, the probability or the level of risk from feed ingredients. Maybe feeding is not as high a risk as previously thought. This will be published later on.